first paragraph is to take a look at the model. And in this particular model, which part of it's still a TRF, but it does change a little bit. This is your template. This is your ratio, 6/25. But you're going to start to see that last part labeled as percentage, because it is still a ratio. It's just a ratio over 100, which is automatically a percentage. And they want you to identify which of these parts with the arrows, which is the part, which is the whole, and which is the percentage. So starting with the 6, is that the part, is that the whole, or is that the percent? Go. Good job. Label it. That's all they want you to do is label that. For the top part is the part. Usually, the top part of the ratio will always be the part. This is the whole. And whenever you see some kind of blank number over 100, if you could figure out what that number is, that will eventually be your percent. From here on out, we're going to call this model TRP. It's like template ratio find, but it's template ratio percent. Okay? All right, let's take a look at this. It's the same thing. Now they give you the words. It says 6 out of 25 players on the Alton Renegades softball team are pitchers. What percent are pitchers? This is still my part. This is still my whole. And this is my percent. What are they asking us to find? The part, the whole, or the percent? What's missing? Luke. Okay. Agreed. Percent, right? Now you're just going to do 4 corners like you've been doing all along from lesson 8, which is when we started this. Where can you connect? Can 6 go into 25 evenly? What about 25 into 100? How much? Do the same thing to the top, and you now have your missing number, which is your percent. By the way, when you go across like this, is it constant or multiplicative structure? Not that it matters what you call it, as long as you use a strategy that works best. It happens to be constant. If you go top to bottom, that's multiplicative structure. So what's our answer? Amanda. Okay, next question. All right, there's 28 students in Mr. Belvedere's class. 25% of those students play in the school orchestra. How many play in the school orchestra? First thing they want you to do is identify the part, the whole, and the percent. What's this? This box here. Nick Ellis. Mike, what goes here? Or what, not what number, what part? Is it the part, the whole, or the percent? Great. Might as well do 28 also, Mike. Part, whole, or percent? And this 25, which they happen to give you. Great. What are they asking us to find? What's missing? Well, I know it seems really basic, but it's going to be important eventually as these get more complicated. Is that the part, the whole, or the percent that they're asking us to find? They gave us the whole, it's 28. They're asking us to find the part. Okay, now we could figure it out. Can 28 go into 100 evenly? 28 into 100? Not quite. Can 28 go into 100 evenly? it going evenly. So now we look top, bottom. What about 25 into 100? Man, you want to try that? Yes, it goes in evenly. So now you have to say to yourself, what times 4 makes 28? Or 28 divided by 4 if you go backwards. Steppy. 7 is 7 out of 28 play in the school orchestra. Did we use constant or multiplicative structure? And the answer is 7. All right, now if you go to the next page, they give you less and less of the model for you. You have to fill out the missing parts and identify what's what. All right, let's do it together. There are 3 students in Mr. Russo's class that are left-handed. Those 3 students represent 10% of the entire class. How many total students are in class? All right, so what do you do with the 3? Go back to VIPs again and underlining what we need. What do I do with that 3? This is my template. This is going to be my ratio. This will be my percent. So that 3's got to go somewhere. Aiden. What? You want to come up and do it? All right, come on up. Just do the ratio part, though. Don't do the whole thing just yet. Oh, I see what you're doing. Okay. I need to stop you because we're not getting it quite right. Erase it. Let's do it together, okay? It's a little slow. Take it piece by piece. I remember, I say this to my students every year. If you see percent, do you see the word percent in the word problem? When they give you percent, they're giving you an entire ratio. Because 10% is what over 100? 10% is what over 100? So, yeah, it's 10 over 100. So let's take care of that first. This is my column right here for percent. 10 over 100. And look, watch. That's my percent. They give that to me. Let's do the ratio together. That 3's got to go somewhere. And this is where it's important. This is why that whole thing is important. You have to say to yourself, that 3, is it part of the class or is it the whole class? Gabby. Right. It's part of a class that happens to be left-handed. It's not the whole class. So that's my part, which is always top. They're asking us to find how many total students are in the class. Where can you connect? Once you have 3 out of 4 corners, look at constant, look at multiplicative structure. Emma Leonard. It does. It goes nice. Times what? So now what are we going to do that 3? You got it. And that happened to be what? Multiplicative structure or constant M. And the answer is 30 total students. See, I know you guys know four corners. When we get to four corners, you're pretty good at that. The hard part is knowing the pieces that they give you, whether it's part or whether it's whole or whether it's percent. Because if you put it in the wrong spots, you're going to wind up going down the wrong road, and you're not going to get the answer right. So really the hardest part is knowing what's what. And it's going to get harder as we go through lessons 27 to 28. So you got to really kind of make sense of that word problem. Sometimes it takes, you got to read it sometimes 3 and 4 times to figure out whether those numbers are representing the part or an entire group. Sometimes it helps to say, well, which number is, one thing, when I get my answer, is my answer going to be bigger or smaller? Because the smaller number is always the part, and the bigger number is always the whole. Okay? You want to try one on your own? Let me see what's coming up. What? All right, I want you to do page 6 in your group. But don't go ahead unless you're advanced. If you're advanced, now you can go at your own pace. Okay? Tell me if you got at least this far, though. My template is part to whole. What goes in the ratio? Come on, I know we got that far. What's the part? What's the whole? Michael. Did everybody get 24 over 60 in the middle here? We don't know the percentage, do we? But we always know this number at the bottom of the percentage, which is what? It's always going to be what? 100. And then you realize, okay, where can I connect? And I can't connect anywhere, can I? Ready? Ready? Watch this. 24/60th. Ready? Ready? Watch. Find the value of the ratio. Find the value of the ratio. You've done that. You did it in lesson 7. Drop, scale down 24/60th as far as it'll go. That's value of the ratio. Get to the value. Not unit rate, but get to the value. Keep breaking it down until you can't break it down anymore. More. You could go more. They're still both divisible by 2. Divisibility rules. No. Keep them whole. Aiden, you're almost there. 4/10 can be broken down a little bit more. Skylar, what'd you get? 2 over 5. Did you get 2 hour? Guys, I can't talk over you. Hey, can't talk over you. When you found the value, when you scale it down, did you get 2 to 5? Some of you did. Some of you are not watching me up here. Okay, so watch what I do. Ready? Can 5 now go into 100? Times how much? Multiply 2 times 20, and you got your percent. Yes? Hug, yes? Okay, so that's a strategy. If you get a number that doesn't work multiplicative structure or constant, then take the ratio that you have both pieces for and scale it down to the ratio.